In section 7.6, we're looking at complex numbers. So the first thing we need to define is imaginary numbers. And so the imaginary number and we use I to denote the imaginary number, is defined as follows. I is equal to the square root of -1, and I squared is equal to -1. The set of imaginary numbers consists of numbers of the form bi, where b is a real number and b does not equal 0. And so for all positive real numbers a, the square root of -a can be broken into the square root of -1 times the square root of a, but the square root of -1 is just I, and so we end up pulling an I out and have just the square root of a left over. And so let's look at example number 1 first. We have the square root of -16 times the square root of -25. The first thing we want to do is pull the I out front. And so the square root of -16 is going to turn into I times the square root of 16. And the square root of -25 is going to turn into I times the square root of 25. And so now we can simplify the square roots because 16 and 25 are perfect squares. So the first term is going to turn into 4i, and the second term is going to turn into 5i. But 4i times 5i is going to give me 20i squared. And what do we know about I squared? I squared is -1. So what we have is 20 times -1, which is just -20. And so my final answer is just -20. And so a complex number, a number that can be written in the form a plus bi, where a and b are real numbers, is a complex number. And so we say that a is the real part and bi is the imaginary part. So two complex numbers, a plus bi and c plus di, are equal if and only if a is equal to c and b is equal to d. So the real parts are the same and the imaginary parts are the same. And so when I add and subtract complex numbers, we add and subtract the real parts and we add and subtract the imaginary parts. So a plus bi plus c plus di turns into a plus c plus b plus d times I. And if I were to subtract a plus bi minus c plus di, I have a minus c plus b minus d times I. So let's go ahead and look at example number 2. We have 6 minus 2i minus 3 minus 5i. And so using the definition above, we're going to subtract the real parts. So we have our 6 and our 3, which is the real piece. And then the -2i and the -5i are the imaginary piece. So as far as the real part goes, we have 6 minus 3. And then we're looking at the imaginary piece. We have -2 minus -5. And that's times I. So we're just looking at the coefficients in front. Well, 6 minus 3 is going to give me 3. But inside our second set of parentheses, we have a double negative. So we end up with -2 plus 5 times I. And so we end up with 3 plus, we have -2 plus 5, which is also 3i. So our final answer is just 3 plus 3i. let's talk about multiplication. So we're going to multiply 7 minus 6i times 2 plus 3i. So we can FOIL or multiply as normal. We're going to multiply 7 to 2 into 3i. And then we're going to multiply negative 6 to 2 into 3i. So we have 7 times 2 plus 7 times 3i. Then we have minus 6i times 2, and then minus 6i times 3i. So let's go ahead and multiply and simplify. We have 7 times 2, which is going to give me 14. Then we have 7 times 3i, which is 21i. We have negative 6i times 2, which is negative 12i. And then our last term, we have negative 6i times 3i, which is negative 18i squared. And so right now we can combine like terms in the middle. We have a 21i and a negative 12i. And what we need to be careful is we have an I squared. So we have 14, we have 21 minus 12, which is going to give me a plus 9i, minus 18, I squared, but I squared is just negative 1. So really what we have is 14 plus 9i plus 18, and we can combine like terms one more time with the 14 and the 18, and this ends up giving me 32 plus 9i. Now let's go ahead and look at division. So division is just like multiplication, but we're going to use conjugates. The goal is to get rid of the imaginary part in the denominator, just like we did with having the roots in the denominator. So what we want to do is we're going to multiply the top and the bottom of our fraction by the conjugate of the denominator. So we have 7 plus I over 3 minus 2i. And so the conjugate of the denominator is just 3 plus 2i. And so that's what we need to multiply the bottom and the top by. And so we're going to end up FOILing or multiplying the top and bottom of the fractions. And so 7 times 3 is going to give me 21. My outside, I'm going to end up with 14i. The inside is going to give me 3i. And then my last term gives me 2i squared. And then we just need to do the same thing in the denominator. So first term gives me 9. My outside term gives me plus 6i. My inside term gives me minus 6i. And my last term gives me minus 4i squared. And so now we want to combine like terms. On the top we have 14i and 3i. And in the bottom I have 6i and negative 6i. But the 6i and the negative 6i are just going to end up canceling. The other thing we want to keep in mind is we have this I squared. So we can replace it on the top and the bottom. So on the top we have 21. We have our 14 plus 3i, which gives me 17i, plus 2 times I squared becomes negative 1, And then in the bottom, we have our 9, our two middle terms canceled, and then minus 4 times negative 1. And so we can go ahead and simplify a little bit further. We have 21 plus 17i minus 2 9 plus 4. And so the last thing we can do is combine like terms again. We have 21 and negative 2 on the top, and then we have our 9 and 4 in the bottom. And so 21 minus 2 is going to give me 19. Plus 17i. And in the bottom, we have our 9 plus 4, which gives me 13. And so a lot of times we split this up so that the real part is by itself and the imaginary part is by itself. And so in order to do that, we're just going to write 19 over 13, and then plus 17 over 13i.